na, mukhang marami na rin naman tayo dito. So it will be on Friday. That will be our schedule. So kung napansin nyo, sa Senate ni Sir Roy, medyo, hindi ko alam kung paano nakapost sa inyo, pero nagdalawa yung ME411, yung exam natin. Pero yung tunay is on Friday yung exam, okay, not on Saturday. So I already prepared our examination, under approval pa siya. So yun yung hinahabol ko ngayon eh. Pero more or less, naman, hindi naman siya magbabago na. Kasi Friday na rin naman to. So discuss ko lang yung content. We started yung ating final examination class. Ang scope niya is from hydraulic turbine, fans, blowers, air compressor. Okay? I said last time na didiscuss sana natin sa wind turbine. However, hindi natin siya makakasama ngayon kasi talagang kulang tayo sa oras. Hindi ko siya pwedeng isingit dito sa discussion ng air compressor. Kasi medyo magkukulang naman yung information when it comes to air compressor. Besides, na-discuss naman yung last semester sa inyo. So I prefer to focus on this topic rather than hatiin siya. So medyo kinulang tayo kasi nga not sure din, napaaga rin yung ating final examination. Dapat parang 18 weeks pa dapat, pero parang 17th week pa lang natin ngayon eh. Plus, nagkaroon pa nga tayo ng mga long weekends and holidays. Okay? So for hydraulic turbines class, hindi ko sinama si velocity triangle sa examination. So everything ng ating every question sa ating final examination will revolve only sa performance ng fluid machinery. So wala akong sinamang velocity triangle sa hydraulic turbine. So one problem related kay turbine, one problem kay fans, one problem kay blowers, and two problems kay air compressor. So hopefully, yung problem set na ginawa niyo last week, that will serve as example, that will serve as exercise para sa inyo, or practice problem para sa inyo. Para yung i-memorize na lang o yung aaralin nyo na lang for this week is yung discussion natin ng air compressor. So hopefully ganun ha. Okay, so any question class related dun sa ating final examination?
Wala naman po.
Wala naman. Sige, okay, hopefully clear yan. Start natin yung discussion natin class ng air compressor. Pipilitin ko rin medyo mabilisan yung topic natin kasi delay na nga tayo ng 30 minutes and then may nag-exam pa kasi sa akin sa labas. So titignan ko pa din sila. Mga nagre-recover ng mga hindi nakapag-exam ng big terms. Okay, so air compressor, same siya ng principal class ng pumps. Same ng principal or working operating condition ng blowers and ng ating fans. Pag sinabi kong same principle, meaning same yung objective niya, it is to increase the energy or to add energy sa fluid or to increase the pressure of the fluid. Diba ganun yung ginagawa ng pump? We're adding energy sa water. Kapag fans and blowers, ganun din, we're increasing pressure or adding energy sa fluid natin. Ang difference nga lang niya, si pump is using water, si compressor is using air. So, ganun yung workflow niya, pero yung basic or yung principle behind that, medyo malaki yung pagkakaiba. Okay? Nagkakaroon tayo dito ng major compression. If we are adding pressure, then bakit nga pala major compression yung tinatawag o compressor? So let's go back to the ideal gas law that states pressure multiplied by volume equals mass times of gas constant times the temperature. So if yung volume gas, ilagay natin dito sa denominator. So pag ganyan yung case, straightforward approach naman, yung pressure is inversely proportional sa volume. So whenever we are increasing pressure ng air, at the same time, lumiliit pala yung volume ng ating air or vice versa. Kung dinidecrease natin yung volume ng air, kasi nga kinocompress natin yung air, di ba? So we are compressing the volume of the air. Ang nangyayari pala, yung sa air na compress natin, tumataas din yung pressure niya. So, compressor is a machinery that increases the pressure of the air. Pero kaya siya tinawag na compressor kasi nga, whenever we're increasing the pressure at the same time, we are reducing the volume of air. O yung method to increase the pressure is by reducing or reduction ng volume ng air. Okay? So based from the ideal gas to also class, yung temperature ng air is directly proportional sa pressure, di ba? So whenever we're increasing the pressure ng air, yung temperature ng air is tumataas din. Meaning, masyadong umiinit yung outlet temperature doon sa compressor. So may significance ba yan? Yes, meron. I-discuss natin yan later on. Base. So yun. Yun lang naman ang basic definition ng air compressor. Pero later on, yung process for that, types ng air compressor, working principle ng air compressor, parts ng air compressor, di-discuss natin. Okay? So simulan muna natin sa industrial uses or saan ba siya ginagamit, mostly na ginagamit. So pag narinig natin yung term air compressor, yung una pumapasok sa isip natin, actually nung time nyo, nung at that age din ako, ang naisip ko lang nun is yung machine, yung small scale machine na ginagamit pang inflate ng gulo. Okay? So yun yung nakikita natin sa mga vulcanizing shop, yung nakikita natin sa fuel refilling stations. Pero in reality class, yung mga air compressor na mga nasa manufacturing plant, nasa fabrication yard, construction yard, whatsoever, sila yung mga industrials, mga large-scale air compressor. So, hindi nyo siya ma-identify. I'll show you later yung configuration niya. Pero ibang-iba siya dun sa usual na nakikita natin sa mga vulcanizing shop or dun sa mga fuel refilling station. So, yung uses niya in terms of industrial application is that pwede siyang gamitin as a prime mover or sa source of power para sa mga hand tools natin. Ano ba yung mga hand tools? Nandiyan yung mga grinders. So we have pneumatic grinders pala. Di ba usually yung grinder natin is electric grinder wherein may motor doon sa loob na siya yung nagpapaikot sa grinder sa cutter. So may mga tools na configured na yung leading source ng power or yung power supply niya is not directly from electricity but from compressed air. Okay? So we have impact wrench, drills, nail gun, cutter nga. So most of them, almost lahat ng mga hand tools natin, yung mga power tools natin, is may ka-accompany na or reconfigured na to have or to supply compressed air para mapagana to. Okay, so yun yung mga basic lang naman. Next is steel production or melting processes ng steel or smelting na tinatawag. So I've never seen this one class, pero ayun sinasabi dito na during the melting processes or smelting processes wherein nagmamanufacture tayo dito or milling, ang tawag ko sa ganyan is milling processes wherein nagpo-produce ng mga steel plates, steel beams, steel pipes, so ever, or steel shapes, gumagamit pala dyan or nagsusupply dyan ng compressed air. Well, it makes sense naman kasi syempre, to create a reaction, di ba, kailangan natin ng oxygen. And for that, compressed air pala yung ginagamit dito. What else? Blasting and painting. So blasting and painting is part sa isang fabrication or construction industry. Siya yung almost nasa last part ng process. So parang siya na yung touch up, siya yung finishing touch ng isang construction process flow. Okay? So from cutting, from welding, from fit up, mapupunta na yan sa blasting and painting. So parang yun na yung ready for delivery na. So kailangan pala ng compressed air dyan. Bakit? Kasi kagaya nito class, sa sandblasting, so makikita nyo dito class, this is a air compressor ha. Parang ano lang yan, kinuha ko yan sa sa parang advertisement ng brand na yan. So yung ginagawa kasi na sandblasting is piniprepare yung surface area na pipinturahan. So for example, this is a steel plate. So to ensure na yung pintura dito class is mag-a-adhere or mag-i-stick ng maayos without any defects, kailangan mo nang linisin yung surface ng ating bakal. Okay? But it's still that, sorry. So that one is still, so hindi siya basta-basta pwede lang punasan. Pag ganun kasi hindi maaalis yung mga kalawang o yung mga mill scale. Pag sinabing mill scale, yung mga natitirang impurities dun sa bakal after ma-produce yung bakal. Okay? So, ang way para malinis na yun is through sandblasting. Yung sandblasting na yan, medyo pressurized yan. Okay? So, parang dinidifuse niya yung sand at tumatama dito sa ating mga surface. So, yung nagsusupply pala ng pressurized sand is through air compressor. So, we have air compressor here at the back. And ito yung ating mga sand. So, to supply pressurized sandware para makapag-blasting tayo, kailangan niya ng air compressor. Okay? So same goes plus dito sa nakikita niyo sa screen, yung painting naman. For painting, well, familiar naman tayo sa painting, di ba? Pero yung usual natin nakikita is through paintbrush or roller brush. Pero to make it efficient, gumagamit tayo ng tinatawag na paint spray. So yung paint spray, nakikita niyo sa canister na to, hindi dito yung ating paint materials or mixed materials. Kaya part A, part B, or yung thinner na tinatawag. So, para makapag-deliver or to evenly distribute yung paint material na yan, kailangan natin ng pressurized air. So, yung pressurized air, dumadaan yan dito sa pneumatic hose papunta sa ating paint gun. Paint gun ang tawag dyan, class, or spray gun. Okay, so it disperses the paint materials para may scattered o kumalat dun sa area na pipinturahan natin. So for that reason, kailangan natin ng pressurized air. And yung pressurized air, nakakonect yan kay air compressor. So ano pa ba? Yun lang nilagay ko dito, pero technically maraming talagang function, maraming uses ang air compressor. Ginagamit niya sa paglilinis class. So kung maintenance, nasa maintenance kayo, mag-overhaul kayo ng isang equipment. For example, pumps. Pupuksan niyo siya, lilinisin niyo, so gagamit kayo ng compressed air para maalis yung mga impurities. Okay? Ganun din. What else? Siguro ginagamit din siya sa ceramic fabrication, yung paggagawa ng mga tiles, ganyan. Ginagamit din siya to move for PLC, you know, PLC, di ba? To move something, yung mga heavy objects. So, kailangan ng door para automated lang, bubuksan yung isang area. So, gagamitin tayo dyan ng compressed air. Pero dapat enough yung supply ng compressed air natin, ha? So on and so forth. Okay? So, for different types ng compressor, actually same lang din to on post dun sa pumps. We have positive displacement and dynamic type ng compressor. So, di ba? Narinig natin yan when we are discussing types ng pump. We have positive displacement pump, dynamic pump. In dynamic, you have centrifugal, we have action. So, ganun din naman dito class kay compressor. Same din yung kanyang, almost same din yung type nila. Pero yung pag-aaralan natin for the sake of our discussion is yung tinatawag na positive displacement, reciprocating type. Okay? So, single acting or double acting. So, dito tayo magpo-focus sa line na to class. Not including the diaphragm. Bakit? Kasi one way to determine daw yung throughput or yung volume na di-displace class ng compressor is through sa design or through the configuration ng mismong type ng air compressor. And yung pinakamadali or the easiest one or yung direct, yung approach nito is by calculating the piston or cylinder size, which is 5d squared over 4 multiplied by the length, di ba? So for now, ang pag-uusapan lang natin is positive displacement, reciprocating type air compressor. Pero for each type ng air compressor, merong iba't iba class na way to determine the volume displaced or yung tinatawag na throughput. Okay? Nakataon lang na the easiest one here is the positive displacement or piston type air compressor. So ito yung ating reciprocating air compressor class. So we have the piston at the inside. So nakikita niyo naman yung piston sa loob. At the same time, we have the cylinder here, yung naka-enclose dun sa ating piston. So yung working principle, I hope aware naman kayo dito. Whenever yung piston moves, for example, it moves at the bottom, then nagkakaroon ng suction side or nagkakaroon ng suction dito sa side na to class. Okay? Then whenever the piston rises up or tumataas yung piston, then at the same time, nagkakaroon ng compression and ng discharge ng compressed air. So ganun na yung movement ng ating reciprocating air compressor. Continuous na nag-reciprocate siya, then continuous na nagkakaroon ng compression process. And yan yung pag-aaralan natin for today. However, nagpakita rin tayo dito ng tinatawag na rotary screw air compressor. Yes, medyo specific ko siyang nilagay dito kasi in every industry, medyo common talaga yung rotary screw air compressor. So, as din siya yung widely used type ng compressor. Bakit? So, sinasabi nila na energy efficient, na pinaka-efficient daw si screw air compressor. Then, yung discharge ng compressed air is hindi nagpa-fluctuate or uniformly yung distribution, meaning medyo control yung pag-provide niya ng compressed air. And pangatlo is through noises. Less noise siya. Okay. Sa positive displacement, siguro the way the piston moves, medyo maingay lang talaga. Pero kapag rotary screw air compressor daw, medyo less noise tayo. So how does the rotary screw air compressor works? So as you can see here, we have two screw type or parang gear na parang merong mesh nag-hit dito class sa gitna. Okay, so whenever nag-rotate yung dalawang screw na yan class, nag-create yan or nagre-reduce yan ng volume sa loob dito. So that reduction ng volume along the line increases the pressure ng air hanggang sa makarating siya sa discharge. Okay? So, for rotary screw type air compressor class, meron pa rin tayong common type niyan. Okay? So, hindi necessary na iisang model lang yung makikita natin. For rotary screw type, meron pa iba't ibang klase yan. We have here the oil-injected and the oil-free. Pag sinabing oil-injected, meaning may oil dun sa loob ng compressor, it serves as a coolant, it serves as a lubricant, it serves as a protection dun sa mga moving parts. Pag oil-free, meaning wala tayong i-insert na oil during the process or during the operation ng compressor. So, yung protection niya, yung coolant niya, yung lubricant niya, is wala. Pero naka-design talaga yung oil-free na yon not to have those or not to have additional oil para maserve pa rin yung purpose. So for that reason, mas mahal si oil-free. But what I'm trying to say here, class, is that kahit na i-specify natin, for example, right now, in-specify natin sa rotary screw type air compressor, meaning pala, napakadaming klase niyan sa market. Okay, napakadaming variation ng type ng air compressor. So, even though i-classify natin sila by reciprocating, rotary, screw, doon din naman sa pumps di ba? Kung naalala niyo yung research niyo, napakadami pa rin variation, napakadami pa rin variety ng pumps. And yun na yung trabaho nyo as an engineer, kung ano man yung magiging work nyo after this, is that, for example, mapa-assign kayo sa mga energy efficiency company or dun sa mga energy auditing company wherein ang function nyo is to audit or to determine yung existing condition ng company or yung operation na yun, i-verify nyo kung effective pa ba or efficient pa ba yung work yung napoproduce or yung machinery na yun. Okay? And by that reason, pwede nyo ma-determine class kung papalitan na ba yung machinery, kung i-retain ba yung machinery or hindi. Kung papalitan na, then kayo na yung mag-a-assign, kayo na yung mag-set anong type, specific type na machinery yung ilalagay nyo. So, kung napili nyo is screw type air compressor, then for those variation ng screw type air compressor, ano yung masasuggest nyo? So, kailangan nyo i-consider, syempre, capacity, power, discuss natin yan later on, cost, particularly, and consumption. Okay? So, for dynamic, we have centrifugal and axial. Hindi ko siya masyadong i-discuss class. Pero yung centrifugal nga is the fluid or the air enters here radially and exit radially as well. Okay? Kaya siya centrifugal. Then kapag axial, then the fluid enters and actually, and it leaves actually as well. Pero during those process, nako-compress yung air. So, proceed na tayo class sa medyo binibilisan ko ngayon kasi baka kapusin tayo ng oras eh. Compressor system. So dito sa compressor system class, ipapakita ko lang sa inyo yung component na meron yung compressor. Kapag sinabi kasi natin compressor, hindi lang siya stand-alone na machinery. So dapat, kagaya ng pumps, dapat may mga pipes tayo, di ba? Pero hindi lang talaga yung plus yung nakakonect doon. Medyo madami pa. Pero for compressor, i-discuss ko sa inyo yung basic lang na requirement dun sa system na compressor. So simulan natin syempre sa motor. So right now naman, at this stage, at this time, yung prime mover or yung source or yung supply ng power ng mga machinery is mostly, siguro mga 90% is talaga ang electric motor. Well, pwede naman daw yan i-connect na sa mga diesel engine, gasoline engine, or combustion engine. Pero right now, sino ba yung gumagawa ng diba? So mostly naman talaga, directly nakakouple yan sa motor. By the way, i-highlight ko lang ito class. Yung ating air compressor, kung nakikita nyo ngayon, meron siyang enclosure talaga. So may mga dotted line yan. Okay? So yung nakikita natin ngayon, pag bumili tayo ng air compressor, as in ganyan, nakabox na siya. So ito yung class. So pag bumili kayo ng air compressor, or pag may nakita kayong ganyan sa planta, air compressor yan. Hindi yan open or readily accessible. Nakasara yan for safety protection, kasi nga may mga moving parts yan, and at saka mainit yan and for noise protection din. Kasi medyo maingay nga kapag nag-ooperate na yung air compressor. So dito, imagine nyo na lang, inalis yung enclosure na yon. So na-expose yung loob ng compressor. So from that, simulan nga natin, we have the electric motor. Saan siya yung nagsusupply ng electricity at nagpapaikot doon sa compressor natin. So yung compressor natin kasi is nakakouple lang dyan. So during the rotational movement ng ating motor, sumasabay din yung compressor, then nakakaroon ngayon ng inlet ng air papasok sa compressor. Then yung inlet ng air na yon, o yung papasok na air na yon, nako-compress siya during sa process, or ini-increase yung pressure, then yung lalabas sa kanya class is the compressed air na. So saan siya pupunta after? So pupunta siya dito sa tinatawag ng lubricant or air separator. So ito yung class. I told you last time, kanina, na may mga compressor wherein oil injected for yung purpose nga to lubricate, to cool, and to ensure na hindi nagkakaroon ng damages during the movements dun sa loob ng compressor. Walang masyadong nagtatamaan. Okay? So it filled the gaps dun sa, lalo kapag screw type air compressor. So during that process, kasi nga may oil, so yung oil na yun, napapasama siya dun sa hangin, dun sa compressed air. Wherein, syempre, hindi naman maganda na po-provide tayo ng compressed air na may kasama siyang impurities such as oil. So bago siya i-release sa production line, dadaan muna siya dapat sa separator. Okay, so once okay na class, at na-separate na yung oil sa compressed air, yung compressed air natin dadaan ngayon sa tinatawag na aftercooler. So, ito class. Yung aftercooler natin na yun class, that is a type of heat exchanger na ang function nga niya is to cool yung temperature ng compressed air. We know that temperature ng compressed air increases along the pressure. So for that reason, hindi rin maganda na magpo-provide tayo ng mainit na compressed air dun sa production line, particularly kung yung ating function or kung ating production line is nagre-require ng um, clean and cold compressed air. So kung nasa food industry ka, kung nasa electronic company ka, then ayun, medyo sensitive ang mga yun, hindi sila nagre-require or dapat talaga medyo malamig. Not necessarily malamig or around the lower yung temperature ng ating compressed air. As I said, pag bumili nga tayo class ng ng compressor, as in package na yan. So nadudulo yung motor, yung compressor mo, yung separator, at saka yung coolant or cooler natin. Okay? Then after passing through the cooler, dadaan yan sa ating distribution line, and it will go first with the dryer. So by the term itself, dryer, purpose niya is to dry the compressed air. So bakit tayo may dryer at bakit basa yung compressed air? We know that the air has a moisture content. Tama? Merong moisture yan ngayon na-evaporate, or sorry, ngayon na-condense at nagiging ulan. So ganoon din sa surrounding natin, surrounding air. So whenever we are compressing the air plus, ini-increase natin yung temperature. And then bigla natin siyang pinalamig dun sa ating outer cooler. So may tendency na ma-condense na yun yung air at mag-produce yan ng condensate, okay? Or ng tubig. And those water plus, pag napasama yan sa compressed air natin and distribute sa production line, syempre it's unnecessary, hindi naman require na merong tubig yung compressed air natin. So nagalagay dito plus dun sa system na tinatawag na dryer. Pero hindi lahat ng manufacturing plant o hindi lahat ng system requires dryer. Minsan naman, okay lang sa kanila na wala. Kasi meron tayo later on dito na tinatawag na drainage. Okay? I will tell you later on. So after passing through the dryer, dumaan naman siya sa yung tawag na air filter. So yung air filter plus, it filters dirt, impurities, dust, o yung hindi naman necessary na mag-provide. So parang ano lang yan, pinifilter na yung mga dumi sa hangin. Okay? Pero dito class, dito sa ating air compressor, meron na rin filter naman yun lalo sa suction side. So kailangan ng filter sa suction side kasi medyo malakas yung pagkakaroon o paghigop ng hangin ng air compressor. Ha? So kung hindi mo siya lalagyan ng filter, talagang pwedeng pumasok dyan is kung anong klase ng particles, which is hindi naman maganda sa ating air compressor. It will cause damages. Next is yung ating air receiver or air tank. So after air filter, pupunta na siya sa air receiver o yung tanke. Okay? Tanks. So ang purpose niya is to store the right amount ng ating air compressor. Ng compressed air. So kung mapupunta naman kayo sa design, wherein kayo yung mag-build ng air compressor system, so even the right size ng tank class is kakalculate nyo. Okay? Depende sa demand yun, depende din sa capacity rin ng ating air compressor. So ano ba ang function ng air receiver? So aside from storing air, kasi nga to ensure na hindi nagpa-fluctuate yung sinusupply ng air class so punta sa production line, to ensure na uniform yung delivery ng air, kailangan natin ng air receiver. So it serves as a parang barrier siya na nag-i-stack siya ng air, compressed air. Then yun muna yung sinusupply niya. Then yung sa compressor, siyempre, siya yung nag-fill up ng ating air receiver. What else? Okay, so another purpose niya, as you can see here class, meron tayo ditong drainage pipe. Since nag-i-store siya ng compressed air, so yung compressed air dun class, nagsisettle. Then yung mga condensate na pupunta sa ilalim, mabigat density ng tubig compare sa hangin, so yung tubig na pupunta sa ilalim ng tangke. Then dito sa ilalim ng tangke, we have drainage connected to a solenoid valve, o yung valve na naka-timer na siya. Every 15 seconds, every 30 seconds, nag-o-open up yan. So siguro mga split second lang. Then, dinidifuse niya o inaalis niya yung condensate na nagsisettle dun sa ilalim ng tangke. So it serves as well as drainage or pag-alis ng condensate dun sa compressed air. And after that, pwede na siyang ma-deliver directly sa ating production. Okay, so yung na-deliver natin dito class is a reliable, stable, clean, and dry compressed air. Kasi ang dami ng pinagdaanan na machinery, di ba? So hindi lang pala compressor yung kailangan, marami pang component after that compressor. Yung compressor pala nating class is same with pa, medyo mga high technology na yan. Modern na rin yung technology na ginagamit. So we have variable frequency drive na nga, wherein minamatch niya yung capacity ng air compressor dun sa requirement ng production line o ng system. Kung si production line nagre-require ng 100% air, then si VFD, i-open up niya yung yung capacity ng compressor or 100% niya para masupplyan yung demand ng production line. Kung si production line nag-break time, then si air compressor is medyo babagal din yung speed niya. Okay? So, by increment, babagal siya, i-match niya yung demand ng ating production line. So, ito naman class is yung typical clean dry compressed air system. So, ang difference lang dito is, palagay ko is yung pagkakaroon ng separator, air and oil separator. Kasi ito is typical clean dry compressed air system. So, same din naman to almost. We have the wet air receiver. So, yun nga, nagkakaroon tayo dito ng drainage or nagkakaroon dyan ng parang valve na magde-drain yan every interval para maalis yung condensate. Then after that, dadaan yan sa ating dryer to ensure na wala ng condensate na mariremain or matitira dun sa ating compressed air. Then after that, it will pass again to air receiver. Okay? Para makapag-store na tayo ng dry compressed air. And lastly, dadaan niya sa ating air filter para sure na clean, dry yung ating compressed air. Kaya siya tinawag na typical clean, dry, compressed air system class. Okay. So discuss muna natin yung way para makapag-select tayo ng compressor. So part pa rin class ng trabaho nyo bilang engineer. So usually we have two problems, not only for air compressor, but for every other machinery or every other equipment. So yung una is yung ipag-design, kayo mismo yung magdi-design kung anong size ng air compressor, anong type ng compressor yung gagamitin. This applies only to all class, not only to compressor. So kayo yung magdi-design from the scratch. Bibigay lang kayo ng requirement, then kayo na yung magdi-design. Kayo yung magmamatch ng available compressor sa market. Okay? At the same time, ang isang trabaho ng engineer is to evaluate yung performance ng existing machinery or air compressor. We have an existing air compressor, then ano yung performance ng air compressor na yun? Efficient pa ba siya? Ito pa rin ba yung nire-require ng production line or ng system? Eh kung hindi na, ano yung ipopropose natin? Okay? O ano yung gagawin natin after that? And for that selection ng air compressor, yung main characteristic or yung primary characteristic na titingnan yung class is yung operating pressure, throughput, and power. So ano ba yung operating pressure? Siyempre, operating pressure, when we're talking about compressor here, we're talking about pressure lang. So pressure at the inlet and pressure at the outlet. And for pressure, for compressor class, since medyo malaking value na yung dinidiscuss natin dito, then yung value ng, or yung unit na ginagamit or makikita nyo, even dun sa nameplate ng compressor, ang makikita nyo yung tinatawag na bar. That is equivalent to 100 kPa. Remember this one class? Or 0.1 MPa. So hindi na tayo masyadong makakita ng kPa or lalo yung Pascal. Ang makikita natin when we're talking about compressor is in terms of unit of bar. Yung compression ratio nito class is kapag fans, remember, as per ASME, that one will be 1:1.11. Kapag lower, that will be 1:1.2. And then kapag compressor, syempre more than 1.2 yung pressure ratio. Pero technically, more than 1.2 is around compression ratio of 3, ratio of 5, 10, or even higher pa nga eh. Meaning, if our pressure is 101.325, so it can reach around 1013 plus kPa. So divide mo sa 100 and that will be around 10 bars. Okay, so yung 10 bars pala is equivalent to 1019 kPa. So medyo malaking pressure talaga yun, di ba? Next is yung throughput. So throughput is yung term na ginagamit sa compressor to determine the gas volume delivered. Hindi ko siya gagamitin dito class para uniform naman tayo. Pero ang ginagamit na term talaga is yung term na throughput kapag sa compressor. Okay? So yung throughput na yun, equivalent lang siya sa volume displaced, cubic meters per second, cubic meters per minute, gallons per minute, or liters per second. Okay? And lastly, yung power required para ma-operate mo yung air compressor. Ma-operate means makapag-provide ng compressor or makapag-compress from 1 PSI or 101.325 kPa up to the required pressure or from pressure 1 to pressure 2. So ano yung required power na kailangan ng compressor? So that required power plus imamatch din niya. So another characteristic na kailangan nyo ma-determine during the design operation ng ating air compressor pero hindi naman necessary talaga na malaki yung effect niya. This is yung tinatawag na overall size. Bakit overall size? Kasi nga medyo large scale yung compressor natin. Hindi na to in human size. As in talaga malalaki to class. So siguro mga half or 1/4 ng room, parang ganun. So kailangan mong ma-determine saan mo siya ilalagay sa inyong factory. Hindi nyo siya pwedeng masyadong ilayo kasi nagkakaroon ng losses throughout kapag medyo malayo yung source papunta dun sa production. Okay? So weight. Bakit weight? Kasi nga medyo mabibigat yung machinery na ginagamit dito. So dapat medyo yung foundation, pag saan mo siya ilalagay, dapat kaya niya i-sustain yung weight ng air compressor. Okay? What else? Even the way to lift the air compressor, kailangan mo siyang i-assess. Yun yung mga lifting plan na tinatawag. So kailangan kasi safe and secure yung way natin ng pagbubuhat or else that will be unsafe and may cause permanent damage sa tao or sa properties. Okay? Next is exit gas temperature. Since we're increasing pressure na every time, 10 times the required or the inlet pressure, and at the same time, tumataas din yung temperature. Later on, we have a formula to determine the relationship between temperature and pressure. So, kailangan nyo rin ma-determine ano yung required or ano yung needed exit gas temperature. And i-match doon yung after cooler para ma-ensure na yung lalabas na compressed air is within the proper range lang. And lastly, yung noise. So noise naman, for now, yung mga compressor is since medyo modern na yung technology, may way na para ma-reduce nga yung operational noise ng air compressor. So yun nga, ini-enclose siya sa isang box. So meron acoustic insulation yun para hindi na siya mag-produce pa ng excessive noise. Okay? So those operating pressure, gas volume delivery, and power, i-verify natin yung later on through equations. Okay? Okay, so move naman tayo sa engineering part ng ating discussion. It's 3:15. Hindi ko lang kung nakahabol ako. Okay, so yung na-discuss natin ng una is just or more on overview. Ano ba yung air compressor, types ng compressor, working principle, components ng air compressor. So ngayon naman is ano naman yung fundamentals ng air compressor. So medyo lagyan natin ng engineering touch, okay? So since nagkakaroon tayo ng compression class, yung compression process pala is governed nung may tatlo tayo dito na compression type. So isothermal, adiabatic, and polytropic. So kung familiar kayo sa adiabatic, ito yung ginagamit natin class dun sa last discussion natin sa blowers. Pero mas i-elaborate natin yan dito. Parang shot lang natin yung sa may blower. Okay? Simulan muna natin sa isothermal. So kung nakikita natin dito, sa isothermal pala is a part or is a type of theoretical compression type. By the word theoretical means by theory lang. So what does isothermal compression means? So nasa screen naman yung meaning. Pakibasa na lang class. Talit mo explain sa inyo ng mas madali sa Tagalog. Okay? ISO, kung titinan nyo class, ISO means equal, isosceles. So ISO means equal, thermal means heat. So equal heat during compression process. So what does it mean? During compression process class, yung work ng compressor, nag-a-add tayo or nag-a-add tayo ng heat during the compression process. And heat is related to temperature. Diba? MCP multiplied by the temperature. So sinasabi dito na equal heat during compression process. So equal temperature din during compression process. So kung nag-a-add tayo ng heat during that process, then paano naging equal yung temperature? So kaya nga siya theoretical class, yung amount or yung rate ng pag-a-add ko ng heat during that process ay meron ding equivalent amount or rate ng heat na nadi-disperse or nare-remove or nagko-cool down after or bago siya may release pa, bago siya ma-discharge. Okay? So the inlet temperature and outlet temperature during isothermal process is the same. Well, kaya nga siya isothermal, kaya nga siya theoretical compression class kasi hindi siya hindi siya realistic. Okay? Well, possible ba to? Well, sinasabi dun sa research, nung nag-research ako, possible naman daw, pero hindi siya economical. And bakit mo siya gagawin, di ba? Pero kung titignan yung class yung ating diagram, PV diagram, i-highlight ko dito yung isothermal. So this is isothermal area. So shaded by green. Among those three, so we have adiabatic, we have polytropic. So highlight natin ang iba. So we have here the polytropic, we have here the adiabatic. So among those three class, kung titingnan nyo, yung area na po-consume ng isothermal is yung pinakamaliit na area among those three. So what does that area represent? That area represents the amount or the required work to compress from pressure 1 up to pressure 2. So bakit siya amount work? Kasi PV diagram yan class. What is PV? Pressure, kilonewton per meter squared, volume, cubic meter. So cancel, it will give us kilojoules or kilonewton meter. And kilojoules is a unit of work. Okay? So based from PV diagram, so hopefully naintindihan natin yun. So based from PV diagram, yung minimum amount ng work o yung amount ng work na nag-require para ma-compress from point 1 to point 2 is minimum kapag isothermal yung compression process. May significant yan since sa yung parang pinaka-minimum, so yung pinaka-ideal, pwede natin gamitin yan later on to determine efficiency or performance ng ating air compressor. So yung tinatawag later on na isothermal efficiency class. So isothermal efficiency, parang i-divide mo lang yung actual work kasi si actual work required mas malaki yan. So i-divide mo lang pala si isothermal work dun sa denominator which is the actual work. Okay? Parang ginawa mo siyang basis, ginawa mo siyang gauge si isothermal work. Kasi siya nga yung pinaka-minimum required para ma-compress at point 1 to point 2. Eh lahat naman sila class, i-compress mo at the same pressure level. From pressure 1 going to pressure 2. Then yung isothermal na nga yung minimum. Okay? Then the law governing isothermal compression is PV raised to N is equivalent to LV. Okay? Yung N dito class is equivalent to 1. So para lang siyang PV equals constant. Yung K dito is constant. Next class is adiabatic compression. So adiabatic compression falls under theoretical compression type din pala. So siya daw yung kabaliktaran. Yung definition class nasa screen, pakibasa na lang din. So siya yung inverse or kabaliktaran ni isothermal compression. Wherein for isothermal compression, yung amount ng work na ina-add mo dun sa system is nawawala or nare-reduce at the same amount din. Okay, so ano yung temperature na pumasok, same din sa temperature na lumabas. Pero kaya adiabatic class is hindi. Si adiabatic naman, the amount of heat you added to the system is hindi siya nagko-cool down. It remains to the system. Yung system natin yung compressed air. So, all the heat generated during the act of compression stays in the compressed air. Well, bakit siya theoretical? Kasi it will never happen naman. We know that for every process, thermodynamics, heat transfer, there will always be losses sa surrounding. Okay? So yung amount ng heat na ina-add mo dun sa air, may mga napupunta yan plus, syempre, dun sa compressor mo mismo, may natatransfer yan sa compressor. At the same time, may natatransfer din sa surrounding air. Kaya naging theoretical siya kasi it will never happen. Wala namang perfect insulation. And yung law na nag-govern dun sa adiabatic compression na yun is equivalent to PV raised to K is equivalent to constant. Yung K natin plus is yung specific heat ratio which is equivalent to 1.4. Okay, so ito yung sa adiabatic compression. Kapag adiabatic ka, then yung K mo doon or yung specific heat ratio mo is equivalent to 1.4. And based from our PV diagram, click lang natin, yung amount ng work required to compress the pressure 1 to pressure 2 using adiabatic. So siya yung pinakamalaki class. So yung maximum amount of work requires to compress air from point 1 to point 2 among those three. Okay? So si isothermal, minimum, si adiabatic yung maximum. Then among those three, ano naman daw yung closest to reality? Diyan tayo papasok class sa polytropic compression. So si polytropic compression class, siya yung hybrid between those two. O siya yung nasa gitna na adiabatic, which is tama nga naman. So ito yung nasa gitna class is the polytropic compression. So siya yung closest to reality yung way ng compression. Yung law governing that is PV raised to N is equivalent to Kelvin, to constant. Then yung N natin plus is tinatawag na polytropic index. That polytropic index will always be less than the specific heat ratio. So if our specific heat ratio is 1.4, then anything less than that is the polytropic index. So once na less than 1.4 na yung ating N value or K value, that is polytropic compression na. Okay? Pero hindi dapat yan bababa ng or mag-i-equal sa 1. Kasi yung 1 natin kasi is isothermal, yung 1.4 natin is adiabatic. So anything in between 1 and 1.4, that is polytropic compression. So nasa gitna lang siya ni isothermal and ni adiabatic compression. Okay? And siya yung closest to reality. So among those three, yung pinakamalaki yung work required to compress is adiabatic. Minimum required to compress isothermal. Then yung in between is yung ating polytropic. Okay? Okay, class. So may tanong ba tayo doon? Pa-confirm naman kasi hindi ko, yung gamit ko kasi ngayon is hotspot. So kahit nasa university ako, wala tayong wifi. So naka-hotspot lang ako. Hindi ko sure kung naririnig niyo ako ng ayos. Class?
Okay naman po, sir.
Okay naman yung dating sa inyo? Pakinig naman.
Yes po.
Okay, sige. Tuloy natin, class. Okay, so determine natin yung relationship between pressure, temperature, and so starting from here class, pwede natin balikan yung compressor selection wherein pag-uusapan natin dito yung pressure, yung volume, and yung power. Okay? So mapapansin nyo na gagamitin natin dito yung characteristic na yun. So, simulan muna natin sa relationship ng pressure at saka ng volume. So, P1 V1 raised to N equals P2 P2 raised to N. Medyo madali ang tandaan. Please tandaan nyo kasi kasi magagamit natin yan. Actually, magagamit natin yan dito sa mga formula sumusunod. Pero sa mga problem, yes, magagamit nyo rin yan. Then, kung yung compression is isothermal, then N is equivalent to 1. Okay? Meaning P1 V1 equals P2 V2 na lang. Kung yung N natin is adiabatic, then that is equivalent to 1.4. Okay? So that will be P1 V1 raised to 1.4 equals P2 V2 raised to 1.4. So for temperature naman, T2 over T1 equivalent to P2 over P1 raised to N minus 1 over N. And pag volume, T2 over T1 equals V1 over V2 raised to N minus 1. So pwede naman yan plus dito. Dito lang siya nag-derive. V1 over V2, V1 over V2. Pwede yan equal to P2 over P1. Then pwede yung substitute yan dito plus. Ha? Kalalabasan niya dito. T2 over T1 equals P2 over P1 raised to N minus 1 over N. Siyempre, hindi natin pinakita. Pakimemorize na lang. Pero yun dun siya nakuha. Then, yung polytropic index natin, meron din siyang relationship dun sa specific heat ratio. So, based from kanina, mas mataas lagi ang value ng specific heat ratio or 1.4 compare mo kay polytropic index. So, si specific heat ratio, hindi na siya, si polytropic index hindi siya tataas kay 1.4 or specific heat ratio. So, kung hindi binigay sa problem at pinapahanap sa atin, then we can use this equation to determine the polytropic index. I-multiply lang natin sila sa polytropic efficiency. Pero usually naman, binibigay na sa problem yung log of Bernoulli compression. So, binibigay yung index madalas. Pero kung hindi class, don't forget this equation. Ha? Okay, so dito naman tayo, volume displaced, the swept volume, piston displacement na tinatawag. So pare-parehas lang yun. Piston displacement, displaced volume, volume displaced, swept volume, all of them are the same. So pag-usapan muna natin yung without clearance. Ano ba yung pag sinabing clearance? So kung ito yung ating compressor class, piston type kung ito yung ating piston type compressor, ang pag-uusapan natin is yung ating piston, pag nag-reach yan sa top most portion or sa top dead center, wala yung gap. There's a zero gap here at the topmost center. And ganun din kapag it moves down to the bottom dead center, meaning walang gap din dito sa baba. Okay. So, meaning, pag merong formula na not considering the clearance, ibig sabihin may formula na i-consider din yung clearance. Okay, gagamitin natin yan or di-discuss natin yan parehas. So yung formula to determine the swept volume or V sub B is equivalent to the area ng ating cylinder or pi d squared over 4. This is the diameter. Okay. Yung diameter class, pag nakabasa kayo class ng 4, that is equivalent to diameter also. Multiply natin yan sa length, or sa length is 1. Okay? Multiply by the speed, rotational speed ng ating piston, times the number of cylinder, kasi hindi lang naman iisa minsan yung cylinder, pinibigay naman sa problem yan. A single cylinder, 3 cylinder, 4 cylinder, so on and so forth. And number of piston in action. So pag sinabing number of piston in action, dalawa lang naman yan, single and double acting. So kapag single acting, meaning meron lang tayong isang discharge or isang suction and isang discharge side. So So, kapag bumaba yung ating piston to the top or to the bottom dead center, nagkakaroon ng suction sa isang part lang. And kapag nagpunta siya sa top dead center, nagkakaroon ng action or nagkakaroon ng compression and discharge sa isang part lang. Pero kapag double active, remember yung discussion natin sa pump, meaning for every movement ng ating piston, meron tayong dalawang suction and dalawang compression and dalawang discharge. Kaya siya tinawag na double active. Okay, so both side ng ating cylinder or both side ng piston is nagkakaroon ng suction, compression, and at the same time, discharge. Okay, so for double acting, kapag pinapakonsider naman yung piston rod, then ito yung equation natin. It will be the initial pi d squared over 4 multiplied by L and N plus yung nasa bottom. So yung nasa bottom natin plus is itong side na to. Yun nga lang, hindi natin sasama yung volume na nako-consume or na-occupy ng ating piston rod. So ima-minus natin yung diameter ng piston rod. Okay? Times kung ilang cylinder meron yan. So yun nga, yung volume displaced, yung throughput tinatawag, per specific compressor daw, is magde-depend mostly sa geometry type ng ating compressor. Kaya pinili natin si reciprocating air compressor, yung piston type, kasi ito yung pinaka-simple, it's the simplest and most indicative, meaning mas madali siya mag-provide ng details kasi pi d squared over 4 multiplied by length compare sa ibang type ng air compressor. So class, to determine yung swept volume ng ibang type ng air compressor, meaning merong iba't ibang formula to do that. Okay? Additionally, in reality, hindi possible na walang clearance yung piston and yung ating cylinder. So nilalagay talaga yun intentionally kasi nga ang purpose nun is to ensure na hindi madadamage or hindi tatama yung piston dun sa ating cylinder. Kasi pag nangyari yun, it will cause permanent damage and compression failure. And for that reason, kapag binigyan tayo sa problem task ng clearance, ang una natin gagawin is to calculate volumetric efficiency. Yes, I'll explain that later, bakit. Pero before that, define muna natin yung volumetric efficiency. So it is the ratio of the actual gas volume transferred by suction pressure to the volume displaced by the piston. So yung volume displaced ng piston sa denominator, ito yung ating ginamit dito kanina. Okay? So that is VD. You know the equation for that. How about yung ating actual gas transferred by suction pressure? That is called the free air delivery. So yung equation natin dyan is using PV-MRT or MR multiplied by the temperature divided by pressure. This is mass of air plus or air yung pinag-uusapan dito. Gas constant, this memorize, 0.287 kilojoules per kilogram Kelvin. Yung temperature natin dito, that is measured at free air pressure and free air temperature. So what is meant by free air? Free air is just the atmospheric air. So atmospheric temperature or atmospheric pressure. So yung ating T sub O, yung free air nga, and P sub O, yung pressure, kung hindi binigay sa problem, only if not given in the problem, that is equivalent to T1 and P1. Okay. Inlet condition. Kung hindi binigay yung condition ng free air, then equivalent lang yan sa inlet condition. Okay? O yung papasok na hangin. Pero usually, FYI class, ang pressure at the inlet, mas bumababa ang pressure niyan. Kasi di ba nasa suction side tayo. So since papasok or pahigop, then yung pressure niyan is nag-create ang vacuum. So mas mababa yung pressure compare dun sa free air pressure. Mas mababa yung suction pressure compare sa free air pressure. When it comes to temperature, mas mataas naman minsan mas mataas yung temperature ng suction side compare sa free air temperature. Pero kung hindi naman binigay sa problem, then we can use this equation. Okay, so For that reason, once na makuha na natin yung volumetric efficiency, makuha na natin yung free air delivery, then makukuha natin ang displaced volume kapag binigay yung ating volume clearance. Okay? So, ganun yung process pala. Pero, paano ba natin gagamitin yung ating volume clearance? Yung tinatawag na clearance or dead space coefficient. So, yung coefficient na yun is just equivalent to clearance volume divided by the displaced volume. Pero minsan hindi tayo binibigyan ng clearance volume, ang binibigay sa atin is coefficient or in terms of percentage. The percentage ng ating clearance volume. For that, substitute natin yan dito sa equation, 1 plus C minus C multiplied by pressure at the outlet or pressure 2 divided by pressure at the inlet raised to 1 over N multiply by pressure at the inlet divided by the atmospheric pressure. So yung atmospheric pressure is just the free air pressure plus. Multiply by the atmospheric temperature divided by the temperature at the inlet. So yung atmospheric temperature, it's just the free air temperature plus. So once we determine using this equation the volumetric efficiency, sabi ko nga, substitute natin yan dito, and we already have the value of free air delivery, then we can determine the displaced volume. So yun yung displaced volume kapag i-consider natin ang clearance or dead space. Okay? Pressure ratio. So pressure ratio lang naman is the pressure from or the pressure of the air at the outlet divided by the pressure at the air at the inlet. So it will show ano ba yung required na, for example, we need a pressure ratio of 10. Then kung yung inlet pressure mo is standard, which is 101.325, then multiply mo lang sa 10, and that will be 1013.25 kPa. Or 10 bar. Okay? So yun yung pressure ratio or compression ratio. Piston speed, twice ng length ng ating piston or ng cylinder multiplied by the speed. That will give you meters per second or velocity. Okay. So, nakapag-provide na tayo ng equation plus when it comes to volume, to pressure, and ngayon naman is yung ating work. So even though work yung term natin dito, compression work, kung yung gagamitin natin na volume here is per unit of time, and yung mass here is per unit of time, then yung magiging result natin dyan is not work, rather in terms of power. So yung work kasi natin plus is in kilojoules kapag metric unit, pero kung per unit of time yung volume, cubic meters per second, then makakaroon tayo dito ng second. And that will be kilowatts. Ganoon din dito class, kung gagamit tayo ng mass in unit of time, then ang magiging value natin dyan is into kilowatts. Pound-foot per second, na later on, pwede natin i-convert into horsepower. Okay, so define muna natin si polytropic compression work. So using polytropic compression work, kailangan natin i-multiply lang yung index to pressure at the inlet, volume at the inlet. Yung volume natin, pwede itong maging free air delivery plus. So pwedeng ito ang gamitin natin. And most of the time, ito talaga yung ginagamit, the free air delivery. Yun nga lang, kasi minsan, si T1 and P1 is equivalent na sa TO to PO. Kaya napagkakamalan siya na siya yung ating inlet volume. But technically, that is the free air volume or free air delivery. What else? Ayun. Then after that, multiply lang natin siya sa ratio ng pressure at the discharge and pressure at the suction. So this is the discharge pressure. This is the suction pressure. P2 over P1 raised to N minus 1 over N. N minus 1. Okay? So yung P1 V1 class, it looks familiar kasi that is equivalent to PV equals MRT. So for that reason, pwede mo siyang i-substitute dito. So yun din naman yan, pinuntan lang natin yung pressure and volume ng mass times constant times the temperature. Yung temperature natin class, by the way, sorry. Reminder lang class, yung temperature natin, excuse, please ensure to convert that into Kelvin. So, pag nilist pala natin yung given, convert that immediately into Kelvin, ha? Kasi kung hindi, magiging mali yung sagot dito. Dapat yung ating temperature dito into Kelvin. Kasi yung ating gas constant is into kilojoule per kilogram Kelvin. So, dapat yung temperature mo dito is into Kelvin. Okay? Ano pa? P2 over P1 raised to n minus 1 over n. Looks familiar kasi pwede natin gamitin yan for ito class. P2 over P1 raised to n minus 1 over n can be substituted with the ratio ng ating temperature, which is T2 over T1. So, di ba? Pwede natin siyang pagpalitin. Okay. So, adiabatic compression. Pag adiabatic compression, yung N natin, papalitan lang natin ng K. Yung K naman natin, constant, 1.4. Then, parehas lang din naman yung class. Yung PV, palitan din natin ng MRT. Okay? Mag-iiba lang yan when it comes to isothermal compression. So yung equation natin for isothermal compression is pressure at the inlet multiplied by the free air delivery or the volume at the inlet multiplied by the natural log of the ratio ng P2 over P1. So pagtan mo lang itong P1, P1 ng MRT1, ito na rin yung equation natin na ito. Then P2 over P1 plus, pwede mo yun siyang gamitin dito. So pag isothermal ka, P2 over P1 is equivalent to V1 over V2. So, pwede mo siyang erase sa N, pero yung N mo nga, pag isothermal is 1. So, yan na lang yung ating relationship. Okay? P2 over P1 equals V1 over V2. Pwede mo rin siyang i-substitute dito class. So, kapag nakita niyo sa problem, at ang binigay is parehas ng volume ng inlet at discharge, at hindi binigay si pressure, hindi, ito ang gamitin natin. We can calculate for the work of isothermal compression. Pero kung ano yung binigay sa problem, halimbawa, sinabi sa problem na polytropic or nagbigay ng index na less than sa 1.4, then definitely yung work na kukunin nyo is using polytropic equation. Ha? Huwag nyo naman gagamitin si isothermal. Unless stated otherwise na pinapahanap si isothermal compression work. Okay, next yung power na tinatawag. So as I said, work or power is just work per unit of time. So kung yung ginamit natin na volume at ginamit natin na mass is per unit of time, then yung makukuha natin dito class is indicated power na and not just compressor work. Pero kung indicator power class, so the indicated power is the work done per unit of time, correct? It is the power derived from the PV diagram or the indicator diagram. So most of the time, yung indicated power or yung real or yung compressor power class is in a form of polytropic compression. Kasi nga ito yung real life, di ba? So yung compressor power is by polytropic compression. Siyempre, unless stated na sinabi na adiabatic compression, edi adiabatic power yung pupuli natin. Okay? Pero kung hindi, edi gagamitin natin dito is the polytropic index. So indicated power can be calculated also using another equation, which is the mean effective pressure multiplied by volume displacement. So yung volume displacement, we have formula for that. Define natin kanina. Yung mean effective pressure class, minsan naman binibigay na sa problem. Okay, so huwag yun ang isipin. Pag binigay yung mean effective pressure, multiply natin sa volume displaced, then makukuha na natin yung indicated power or indicative power. And since we are talking na about power, ang kasunod na yan is efficiency. And para madaling maintindihan natin sa efficiency, we still have here the energy flow diagram. Since parehas lang ng operating condition yung ating compressor, kay fans, blower, at pumps, then all of them requires an electric motor para magpagana or magpatakbo sa ating compressor. And for that reason, yung electric motor magpo-provide niya ng tinatawag na input power. So, yung input power or motor power na tinatawag, yung ipoprovide ng electric motor is syempre less than that kasi nga may mga motor losses, may mga winding losses. So yung real power na required na magpaikot sa compressor, ang tawag sa kanya is shaft power or brake power. Okay? Then from that brake power, yung ilalabas na power ng compressor class to compress the air, ang tawag sa kanya is compressor power or indicated power. Okay? So, by energy balance or by energy flow, we can say that the shaft power or brake power is greater than the indicated power kasi nga may mga losses during sa compression or sa compressor natin. And the input power is always greater than the brake power. Or vice versa, pwede natin sabihin yung approach dito na yung work required or yung power required to compress the air from P1 to P2, ang tawag sa kanya is indicated power. Then from indicated power, may mga losses yan. Then yung required na power para mapagana si compressor, ang tawag sa kanya is brake power. So ganun din, mas malaki pa rin si brake power to indicated power. Okay? Hopefully that's clear. And ito na nga tayo sa efficiency. So for efficiency class, ang efficiency ng compressor is compressor power divided by the brake power. So ito lang yun. So efficiency ng compressor is indicated power or compressor power divided by the brake power. Motor efficiency, di ko sinama dito kasi redundant na naman to. That is just the brake power divided by the motor power. Okay? Ulit-ulit na rin naman siya kaya hindi ko siya sinama. Overall efficiency, multiply nyo lang si compressor efficiency and motor efficiency. Or vice versa, you can determine the overall efficiency by dividing the compressor power into the motor power. Okay? And lastly, yung tinatawag na isothermal efficiency. So ito nga yung sinasabi ko, pwede natin i-gauge yung actual work performance ng compressor based from isothermal power. Kasi nga si isothermal power yung minimum work required para makompress yung air from point 1 to point 2. Then from there, ano naman yung actual power? Paano mo siya may compare dun sa isothermal power? And yung relationship ng dalawang yun is tinatawag na isothermal efficiency class. So isothermal efficiency is just the isothermal power divided by the indicated power. So gamitin muna natin class yan lahat sa sample problem. Oh my God. Di ko lang siya na-delete dito. Sige, basahin muna natin class. Medyo bilisan ko na lang kasi we only have 1 hour. Meron pa tayong multi-stage eh. Okay. For 1.0, a single cylinder, just take note of this. Single acting air compressor has a cylinder bore has a diameter of 160 millimeter and a stroke of 300 millimeter. So stroke natin is equivalent to left lang ha. So it draws air into the cylinder at a pressure of 100 kPa at 37 degrees Celsius. So pwede na ito class ang ating free air condition or yung ating inlet condition. The air is then compressed to a pressure of 650 kPa. So this is the final pressure. Then if the compression runs at 2 revolutions per second, determine the mass of air compressed via the cycle, the work required via the cycle, and the power required to drive the compressor. Since hindi naman sinabi sa problem class, then this is equivalent to V sub O, P sub O, 100 kPa equals to P1. Temperature ng free air equivalent to temperature ng suction side. Okay? So ito lang din yan. Convert nyo lang class lagi ang temperature na given into Kelvin. From the given pa lang, convert nyo na para hindi na kayo magkamali. Reminder yun ha. Okay, so how to determine the mass of compressed air? So we can do that using the equation PV equals to MRT. So mass is equivalent to the volume, the free air delivery, multiplied by the pressure, divided by the gas constant and the temperature at the inlet. Okay? So hindi tayo binigyan dito class ng free air delivery. So yung kukunin natin yung volume dito is yung displaced volume. Hindi rin tayo binigyan dito ng clearance. So for that reason, ine-neglect natin yung value ng clearance sa ating cylinder. So yung yung value ng ating displaced volume, we can use this equation class. So displaced volume is equivalent to pi multiplied by the diameter. Ang diameter nga natin dito is 160 millimeter squared divided by 4 times the length, which is 300 millimeter. Kailan pa ba natin ng speed? Hindi na class kasi ang pinapahanap sa atin is compressed air gas cycle. So eliminate muna natin dito sa equation yung speed. Number ng cylinder is 1. So you can see here, single cylinder. So times 1 lang yan. Number of piston in action, single acting air compressor, meaning 1 din yan. Okay? So ito lang yung equation natin. Kaya ang nakuha nating value class is 6.032 times 10 to the negative 3 cubic meter. So substitute na yung mga given, makukuha niyo yan class. Then since meron na tayong volume displaced that can be equivalent to free air delivery kasi wala namang ibang binigay, then we can calculate for the mass per cycle. We have pressure at point 1, which is 100 kPa, temperature of 300 Kelvin, converted into Kelvin, universal gas constant of 0.287 kilonewton per kilojoules per kilogram Kelvin, cancel the unit, kilonewton, Kelvin, cubic meter, meter squared. It will give you a unit of kilogram. So per cycle kasi yung hinihingi, meaning that is 0.007 kilogram per cycle. Bakit per cycle yung nakalagay dyan? Kasi every cycle class, may pumapasok at may lumalabas na 0.007 kilogram of air. Next class is the work required per cycle. So, since binigay sa problem class na, assume the compression process follows PV equals constant. So, hindi ko talaga siya sinama kanina. So, introduce natin dito. Meaning, ang process pala dyan is isothermal. PV equals constant is isothermal. So, from there, balikan natin yung ating formula for isothermal. So we can use these two equations, which is highlighted in red. We have pressure at point 1, correct? Volume, correct? P2, P1, we have. Mass, we have. Temperature at point 1, we have. P2, P1, we have. So both of them, kapag ginamit niyo yan or sinubstitute niyo yung value, isa lang dapat yung magiging result. Dapat isang work required per cycle lang yung makukuha nating value. Okay? So pressure at point 1 is 100 kPa. Volume, yung nakuha nga natin na 6.032 times 10 to the negative 3. Then, multiply by natural log ng ratio ng P2 over P1. Ang P2 natin 600 kP, 650 kPa, P1 is 100. Then we can have the value of 1.13 kilojoules. You can use this equation as well, plus dapat parehas na yung magiging result. And lastly, pinapadetermine sa atin ng power required to drive the compressor. So we have the work. We know that the power is equivalent to work per unit of time. So kailangan lang natin ng per unit of time dun sa kilojoules. So natin siya makukuha dito sa ating rotational speed, which is 2 revolutions per second. So i-multiply lang natin yung nakuha nating work, that is 1.13 kilojoules kada cycle. Multiply natin sa 2 revolutions per second. So kilojoules per cycle or kilojoules per revolution, cancel. That will give you 2.26 kilowatts. So yung isang cycle class is equivalent to isang revolution. And yung nakuha nating work dito is kilojoules per revolution or kilojoules per cycle ng ating piston displacement. Kasi nga piston displacement yan, gumagalaw lang yan. And yung isang cycle niya is from down to up. Okay, example 2.0. We have three examples here for single stage compressor. We have also class na multi-stage. So example 2.0, medyo direct approach din to, kagaya kanina. An air compressor takes in air at 1 bar and 20 degrees Celsius. So that is the pre-air condition natin. Or since wala namang ibang binigay dito sa problem, that is the suction condition as well. Compress daw ito according to law of PV raised to 1.2 equals to C. So in this way, binigay sa atin ang index na 1.2. So may mga ganyang case plus, kapag binigay na PV raised to 1.2 equals to 6, so kukunin lang natin doon yung ating polytropic index. Since that is less than 1.4, meaning polytropic yung magiging compression natin dito. It is then delivered to a receiver at a constant pressure of 10 bar. That is the outlet pressure. And R is equivalent to 0.287 kilojoules per kilogram Kelvin. So yung temperature na 20 degrees Celsius plus, convert lang natin sa Kelvin or absolute temperature, which is 293 Kelvin. Ang P2 will be 10 bar. Ang P1 is 1 bar. And binigyan tayo dito ng universal gas constant. Pero kung tayo binigyan plus, gagamitin pa rin natin yun, 0.287 kilojoules per kilogram Kelvin. Yes. So ang pinapahanap is temperature at the end ng compression and work done during compression per kilogram of air. So saan natin pwedeng kunin yung temperature at the end of compression? We can go back to this equation. Since binigay class yung pressure at point 2, 10 bar, pressure at point 1, which is 1 bar, temperature at point 1, I think 27 degrees Celsius, convert natin to Kelvin na lang, makukuha natin class ang value ng T2. So yung T2 natin is yung temperature at the outlet ng ating compressor. Binigay din naman sa atin ng polytropic index. Okay? So one unknown, one equation. Basta convert to class yung ating temperature to Kelvin, makukuha niyo yung tamang sagot dito, which is 430 Kelvin or 157 degrees Celsius. Okay? So that is the relationship between the pressure and the temperature. Next naman is the work done during the compression per kilogram of air. So yung equation natin class, gagamit tayo ng MRT1 over N, equivalent to work. However, since per unit of mass yung pinapahanap sa atin, edi i-transpose natin yung mass dito sa baba. Okay, so that will be, or divide both side by the mass, it will give us this equation. We have R, temperature at point 1, pressure at point 2, pressure at point 1, polytropic index, then one unknown, one equation lang tayo, makukuha natin ang sagot na 236 kilojoules per kilogram. Okay, class? Then, last example for single stage air compressor. Iisip ko lang. For a while, class, ha? Balikan ko lang yung nag-exam sa labas. Thank you for waiting, class. Sorry. Meron kasi ako nag-exam sa labas eh. So, verify ko lang yung status. Okay, so for example 3.0, basahin muna natin. A 4-cylinder, so nagbigay tayo ito ng 4-cylinder. Sabi nga sa inyo, binibigay naman sa problem kung ilang cylinder yung available. So 4-cylinder double-acting compressor is required to compress 30 cubic meter per minute of air at 1 bar and 27 degrees Celsius. So we have given here a free air delivery of 30 cubic meter per minute. The condition ng ating free air which is 1 bar and 27 degrees Celsius. So kung hindi in-specify, that is equivalent lang sa ating suction condition or pressure and temperature sa suction side. Iko-compress daw to sa 16 bar, meaning medyo mataas to class kasi times 16 or 160% yung increase ng pressure dito. Pero single stage pa din yan. So balik pa rin tayo dun sa equation natin for single stage. And determine the size of the motor required and cylinder dimension if the following data is given. So yung size ng motor class, that is power ng motor, ano yung motor rating na tinatawag. Okay? So tayo muna dito doon at pinapahanap sa atin yung cylinder dimension. So binigay din dito yung speed ng compressor, which is 320 RPM. The stroke to bore ratio of 1.2, meaning yung stroke natin or yung length is equivalent to 1.2 times the diameter. Bakit? Kasi stroke to bore ratio, length over diameter is equivalent to 1.2 over 1. So length is just equivalent to 1.2 times the diameter. The clearance volume of 4%, mechanical efficiency of 82%. So the efficiency, later on, gagamit natin yan to determine the size of motor. So binigay yung efficiency of 82%. The polytropic index of 1.32, polytropic na siya kasi less than 1.4. So assume daw na yung pressure, na walang pressure change sa suction valve. Meaning yung binigay pala class dito nga na 1 bar is the pressure of the free air. Pero since wala naman daw change sa pressure sa suction side, then pressure na suction is equivalent to pressure of the free air, which is equivalent to 1 bar. And air gets heated by 12 degrees Celsius during the suction stroke. Meaning, during suction daw, tumaas yung temperature ng air by 12 degrees Celsius. So the given 27 degrees Celsius air class is the free air temperature. To determine the temperature at the inlet, so that will be free air temperature plus increase of 12 degrees Celsius. Okay? So 27 plus 12, that is 39 degrees Celsius. As I said, convert lang natin yan lahat into Kelvin. Okay? So ano pa yung binigay dito? Binigay sa atin dito plus yung ating ingat. Binigay dito plus yung ating clearance volume, which is 4%. So let's go back to the volumetric efficiency here. Yung binigay sa atin dito is the percentage. So kung titingnan natin dito plus yung coefficient or clearance coefficient, it is VC over VD. Meaning yung binigay na 3% doon or 4% doon rather is the percentage ng clearance volume with respect to the displaced volume. So that is 4% na yung binigay. And to determine nga yung size ng ating air, ng ating cylinder, so kailangan muna natin makuha yung ating volumetric efficiency. So using this equation, substitute nila yung C dito, makukuha natin ang volumetric efficiency. And from there, calculate natin si free air delivery, substitute it here, makukuha natin ang displaced volume. And from the displaced volume, makukuha na natin yung diameter and yung ating length. Okay, so ano muna, balik muna tayo sa problem. Try natin isolve muna yung unang hinihingi. Determine the size of the motor required. Yung size ng motor required, mga galing yan sa equation ng power or ng compressor work. So from here, N over N minus 1, which is 1.32 yung N, multiply pressure at the inlet, which is 1 bar, multiply by the volume ng free air or the free air delivery, which is 30 cubic meters per minute. Convert natin yan later on sa seconds. Then, multiply natin sa ratio ng discharge and the inlet pressure. So 16 bar and 1 bar raised to n minus 1 over n, then minus 1. So lahat naman given class, makakalculate natin ang value ng power. So cancel lang natin yung unit. 100 kPa, since that is 1 bar, is equivalent to 100 kPa. So cancel natin into volume, cubic meter. That will give you 1 unit of meter. Cancel minute. That will give you seconds. Okay? And that will be 197.676 kilowatts. Pero hindi pa yan yung hinihingi sa problem class kasi binigyan tayo dito ng mechanical efficiency. So to determine the size ng motor, i-divide lang natin yung nakuha nating 197 kilowatts into 0.82 to determine the brake power, okay? O yung required power ng motor. And that will give us around 241 kilowatts plus. So yun yung final answer natin doon sa unang hinihinging problem. Next is yung ating cylinder dimension. So na-explain ko nga kanina kung paano siya makalculate. Kunin muna natin yung volumetric efficiency using the clearance volume or the clearance ratio. Okay, so yung equation natin is 1 plus C minus C multiplied by P2 over P1. Yung P2 natin is 16 bar, P1 is 1 bar, raised to 1 over N, N is 1.32. Then, multiply it by P1 over pressure at the atmosphere. Since equivalent lang sila, binigay sa problem na no pressure change in suction valve. So that is 1 bar lang para sa free air and 1 bar para kay suction pressure. So that is equivalent to 1. We can cancel that. For a while class. Okay, class. Ayun, isa na tayo. Okay, so for volumetric efficiency, cancel ko dito si P1 over PATM kasi parehas lang sila ng value. Sinabi kasi dito na no pressure change in suction valves. Okay? Then, i-multiply natin yan sa temperature ng atmospheric or atmosphere divided by sa temperature ng suction. So, ano yung atmosphere temperature natin? That is equivalent to 27 degrees Celsius. Convert lang only into Kelvin. And that will be 300 Kelvin. Divide natin sa suction temperature wherein yung ating atmospheric temperature is heated by 12 degrees Celsius. So that will give us 312 Kelvin. Okay, so lahat naman is given plus. So do the math, makukuha nyo yung sagot na volumetric efficiency of 72.6%. And that 72.6% plus, gagamitin natin yan to determine the displaced volume. Okay, so substitute in the equation, volumetric efficiency is equivalent to free air delivery divided by the displaced volume. So yung free air delivery natin, binigay yan sa problem as 30 cubic meters per minute. So one unknown, one equation, makukuha natin yung free or displaced volume na equivalent to 41.335 cubic meters per minute. Okay, class? And from this equation, lipat lang natin. Madidetermine na natin yung size ng ating motor. Sorry, yung size ng ating cylinder. So displaced volume, which we have already the value of 41.335 kilonewton per cubic meter, is equivalent to pi multiplied by the diameter squared over 4. So yung diameter na yung hinahanap natin. Multiply natin sa length. Yung length natin can be as a function of the diameter. So here, length is equivalent to 1.2 times the diameter. So stroke to bore ratio equals 1.2. So yung stroke doon is yung length. Yung diameter doon is yung bore. So binigay nga dito na length is equivalent to 1.2 times the diameter. So we can assume or we can say that this is 1.2 times the diameter. Ang galing yan dito class sa stroke to bore ratio of 1.2. Next is rotational speed. So yung rotational speed natin class is binigay sa problem of 320 revolutions per minute. Number of cylinders, that is 4 cylinder, sinabi sa problem, and number of piston in action, that is double acting compressor. So meaning 2. So we have all the givens, one unknown, which is in the form of diameter. So we can calculate that to determine the diameter. And yung lumabas sa value is 0.26 meters. Okay? Then to determine the length, edi multiply lang natin yung nakuha nating diameter of 0.26 by 1.2. Okay. And the result will be 0.31 meters. Okay, class? Any question on that? Walang question, class? We can proceed with the next topic.
Wala naman.
Wala naman po.
Thank you. So, proceed tayo sa next topic natin. So, ito yung ating last discussion, class. The multi-stage compressor. Okay, so yung discuss natin nung una is single stage lang siya. Meaning, yung pressure natin doon from point 1, in-increase lang natin yung pressure, single stage, up to point 2 lang. Okay? So, walang interval yun. Pero kapag pinag-uusapan natin, class, is multi-stage na, meaning, we are increasing the pressure here, hindi lang iisang beses. Okay? So, for example, this one, we're increasing the pressure from point 1 to point 2. And then from point 2, again, we increase that pressure of air up to point 3. So yung analogy natin dito, or yung similarity natin dito, is yung kagaya nung na-discuss natin dati sa pump, na in series connection. In series connection, ang objective natin doon is to increase the head of the pump, di ba? So ganito din when it comes to multi-stage compressor, we are increasing also the pressure, kaya ginagawa natin yan. So yung main reason kung bakit natin i-consider yung multi-stage is yung tinatawag natin na pressure ratio or compression ratio. So minsan nga, sa sobrang taas ng compression ratio, hindi na siya kayang i-meet ng single stage. So we have here a basic guidelines. May table tayo dito na guideline or ano lang siya, parang brief or rough guide lang na pag corresponding compression ratio, so for this one, for any corresponding compression ratio, may corresponding siya na number of stages. Okay? So, pag sinabi dito na kapag ang compression ratio mo is parang 1 to 3 lang, then recommended na single stage lang yung gamitin natin. Kapag more than 15, dapat 3 stages na. And kapag 7 to 10 na yung compression ratio natin, then that is 2 stages. Yung compression ratio nga natin is the ratio ng pressure at the outlet and pressure at the inlet. Okay? Ano pa? Yung difference naman niya class kay pump is that yung first stage ng ating compression, nagre-require tayo ng tinatawag na intercooler. So ano ba yung ginagawa ng intercooler? Intercooler is a type of heat exchanger class. So kapag perfect, pag sinabi dito na pag perfect and complete yung ating intercooler, meaning ang purpose niya is to ensure na yung magiging temperature paglabas ng ating intercooler is the same temperature lang nung pumasok dun sa ating low pressure cylinder. Ulitin ko since two-stage na yung compression natin class, so magko-compress muna tayo ng air from point 1 to point 2. So ito yun. From point 1, i-compress natin yung air going to point 2. So at the inlet ng low pressure cylinder, so this is a low pressure cylinder, we have a condition called pressure 1 and temperature 1. So mostly that is close to ambient condition. So once na-increase na natin yan, then yung pressure 2 natin class, medyo mas mataas na ang pressure niya compare dun sa pressure 1 kasi dumaan na siya sa compression, mas mataas na yung pressure niya. At the same time, mataas na rin yung temperature niya. Cold temperature 2. So kung gusto mo siyang i-compress pa ulit into another stage, yung next nga natin is yung multi-stage or high pressure, kailangan mo natin idaan yung ating compressed air, intercooler. Yung intercooler, it serves as a heat exchanger kung saan nga binababa nito yung temperature ng ating compressed air. So we know that yung temperature to natin is high value. So pag dumaan siya sa ating intercooler, ang gagawin ng intercooler, ibababa niya yung temperature up to temperature 1. Ano yung temperature 1? That is the same as the suction temperature lang. Yes, kasi perfect and complete yung ating intercooler. So in reality, hindi nangyayari yun. Kasi never naman i-match natin yung outlet temperature ng intercooler dun sa inlet temperature ng ating low pressure. Pero since for the sake ng discussion natin, i-assume natin na perfect yung intercooler, complete yung intercooler, so yung mangyayari dito, yung outlet temperature dun sa intercooler, napapasok ngayon dun sa ating high pressure cylinder, has a temperature the same as yung ating inlet temperature ng ating low pressure cylinder. At the same time, yung pressure plus ng ating compressed air, di ba, we have a pressure at point 2. Pag na-compress ng ating low pressure, ito-compress yan to point 2. So, much higher pressure. For example, 5 bar. Yung pressure na yan plus is hindi pala nagkakaroon or hindi bumababa. Kapag pumasok yan sa intercooler, walang pressure drop na nangyayari. Which is in reality, hindi naman totoo yun eh. Kapag dumaan yan sa series of tubes, kasi intercooler natin is heat exchanger, so pag dadaan yan sa maraming tubes, papalamigin yan, at pag pinalabig natin, di ba, nababa rin yung pressure kahit paano. So never na magiging, in reality, never na hindi magkakaroon ng pressure drop. Pero since sinabi dito, at yun ang condition natin, then sige lang, sundan natin yun, na perfect ang ating intercooler, complete ang ating intercooler, meaning hindi nagkakaroon ng pressure drop pag dumaan siya sa ating intercooler. So yung compressed air natin at P2, pag dumaan siya sa intercooler, that will still remains at P2. At pag lumabas siya sa intercooler, that will remains at P2. Pero para hindi tayo malito, ginawa ko na siya na P sub X. And medyo sanay na rin ako na term as P sub X kapag intercooler eh. Okay? Then once again, pag pumasok siya sa ating high pressure, i-compress na ulit siya up to 0.3 naman. Okay, so yung difference niya kay single stage. Yung single stage kasi one-time compression lang yan. Kapag kay intercooler, dalawang compression tayo, dalawang stage. Yung difference nila is that yung outlet temperature ng single stage definitely mas mataas compare sa outlet temperature ng ating multi-stage. Ano pa? Yung work required to compress from point 1 to point 2 sa single stage, same compression ratio lang to will require a much higher work compare kapag yung multi-stage. Later on, we have a comparison for that. We have an example problem for that. What else? Okay. So to determine plus the work required for the multi-stage, so yung kukunin lang natin dito is the pressure ratio between the point 1 and the intercooler pressure. Or ang kukunin natin is the pressure ratio between the intercooler pressure and the high pressure cylinder. Since parehas lang yung pressure compression ratio or pressure ratio from point 1 to intercooler or from intercooler to point 3, then yung work per each compressor is equivalent lang. So to determine or para makuha natin yung total work, pwede natin kunin yung isang work lang per each cylinder. Then multiply lang natin sa 2 kung siya is 2 stage. Kung siya naman is more than 2 stage, then multiply lang natin sa kung gaano kadaming stages yun. So, yung dinidiscuss ko kanina, convert natin sa formula. As I said, to determine the work ng isang stage, kailangan mo natin ma-determine yung pressure na meron yung ating intercooler o yung pressure dun sa ating intercooler. Yung paglabas dun sa first stage, papasok sa intercooler, papasok na naman sa second stage. Isang pressure lang yan, tawagin natin siyang intercooler pressure. So yung equation niya is square root of pressure at the inlet and pressure plus dun sa outlet. So yung kalabasan dyan plus is ito, P sub X. Then that P sub X, gagamitin natin yan para ma-determine ang work required or yung power ng ating multi-stage. So for this one, this is 2 stages, kaya multiply lang natin siya sa 2. Okay? So yung gagamitin mong pressure ratio dito plus is yung pressure ratio from P sub X up to P sub 1. Pwede mo rin naman gamitin to plus P sub 3 over P sub X. Parehas lang naman yung pressure ratio na yun dito. And kapag multi-stage yan, so dito class is 2 stages lang. Pero kapag multi-stage, edi palitan niyo yung 2 kung ilan dami or kung gaano kadami yung number of stages. So replace 2 by how many number of stages meron. Okay. And ganun din kapag kukunin natin yung intercooler pressure. So kapag multi-stage, so replace lang itong 2 kasi this is 2, right? Square root. So replace that with number of stages or S squared of P sub 1 raised to S minus 1 or number of stages minus 1 multiplied by the final pressure. Since this is multi-stage, so syempre hindi ko alam kung ilang stages yan. Is it P sub 1, P sub 2, 3, 4, 5, so on. Then, general na lang natin and ilagay as the final pressure. And lastly, the delivery temperature after each stage. So, delivery temperature after each stage. So, kukunin lang natin yung temperature dito sa point 2, temperature dito sa point 3. Okay, so based from this figure class, since yung temperature natin dito, going inside or yung papasok sa ating high pressure is the same temperature dito. Yung papasok sa ating low pressure, then they have the same pressure ratio, di ba? P3 over Px and P2 over P1, they are the same pressure ratio lang naman. Meaning, yung T2 natin is magiging equivalent siya kay T3. Yung outlet temperature dun sa low pressure at outlet temperature sa high pressure, magiging equal lang yung value nila. So it can be represented by this equation. T2 is equivalent to T1 multiplied by P sub x over P sub 1 raised to n minus 1 over n. Ganun din sa T3 equals to T1 multiplied by P sub 3 over P sub x raised to n minus 1 over x. Kasi nga si P sub x plus and P sub 1 is equivalent lang kay P sub 3 over P sub x. Ito yun. So, pressure mo at point x over pressure at point 1, yung ratio nilang dalawa has an equivalent value sa pressure at point 3 and pressure at point x. Okay. So, kung ganun yung case natin, then T2 will be equal to T3. So, pressure ratio relation, na banggit ko na naman, ito nga lang is magdidepend sa kung gaano kadami ang stages. Oh. Lastly is yung heat rejected in the intercooler. Since yung intercooler natin is a form of heat exchanger glass, so sinasama din natin yan sa consideration para ma-determine ano yung required size or capacity ng intercooler natin. And to do that, kailangan natin ma-determine kung ano yung heat, amount ng heat na nare-reject sa intercooler or kailangan ma-reject sa intercooler. So we have the value for T1. Yung T1 nga, kung titingnan natin dito class, that is the temperature na dapat ma-achieve ng intercooler. Dapat ma-match niya yung temperature na papasok dun sa ating low pressure cylinder. So we have the value for T1. We have the value for T2. Ito yung temperature na palabas dun sa ating low pressure stage compressor. Okay? We have the mass of air and specific heat of air. So for that reason, MCP delta T, makukuha natin yung ating heat rejected in the intercooler. Once na makuha natin yung heat rejected, then from there, mamamatch na natin yung tamang size ng ating intercooler o ng heat exchanger. Okay, so pag hindi binigay sa problem, we can use this, we can use this specific heat of air, 1.005 kilojoules per kilogram Kelvin. Yung mass, kukunin natin yung sa mass of air, PV equals MRT, or PV over RT is equivalent to mass of air. Then, difference ng ating temperature, given na naman yan. Temperature at the inlet, which is T1, and temperature dun sa outlet ng ating air compressor. So, T2 or T3. Parehas lang naman yung value nito dito. Then, for two-stage, kailangan natin ng isang intercooler sa gitna. Okay? For 3 stages, kailangan natin ng dalawang intercooler sa gitna. So pag 4 stages, kailangan natin ng 3 sa gitna. So on and so forth. So kung gaano kadami yung ating stages, bawas, mag-subtract ka lang ng isa, then gaano kadami na yung ating intercooler. Kaya ganito yung ating nilagay na equation. So kung dalawa yung ating stages, so 2 minus 1, that will be 1. Kung 3, edi 3 minus 1, that will be 2. Multiply MCP delta T. Okay, class, gamitin natin yun sa equation or sa exercises. So we have last example here. Linisin ko lang class, ha? Okay. It is desired to compress the 16 cubic meters of air per minute. So this is the free air delivery from 1 bar. So yung 1 bar natin and 294 Kelvin, that is the suction condition or the suction condition of the air to 10.5 bars. So 10.5 bars is the outlet pressure. So yung pinapakalculate sa atin dito is the minimum power required to drive the compressor using two stages and compare it with the power required for the single stage. So ito nga, kaya naglagay tayo dito class ng figures or ng diagram for single and two stages para ma-compare natin. So kapag single stage, yung value dito class is 10 bar. Yung value dito is 1 bar. Ganoon din naman kapag multi-stage ka or two stages. So dito we have 1 bar. Here we have 10 bars. Yun nga lang ang difference kapag two stages tayo, magkakaroon tayo ng dalawang compression. So immediately kasi kapag single stage, i-compress mo yung 1 bar directly into 10 bars. Okay? Pero kapag two stages ka or multi-stage, hahatiin mo yung compression na yun. I-compress mo siya from 1 bar to a certain level. Makukuha naman natin yan using this equation. Square root of P1 multiplied by P3 equals Px. And then again, from that Px, i-compress mo siya to the final pressure of 10 bar. Okay? So yun ang unang hinihingi sa problem. Pangalawa is determine the maximum temperature in two cases. So yung maximum temperature class kapag single stage, siyempre, yung ating point 2. What is the temperature at point 2? While kapag two stages tayo, siyempre yung temperature mo rin sa point 2, pero equivalent na yan sa temperature mo sa point 3. So any of those two, pwede mong kunin kasi equal lang naman yung temperature nila. Next is the heat to be removed in the intercooler per minute. Yung heat to be removed in the intercooler per minute, pwede natin gamitin yung equation na to class. mCp delta T. Okay? So we have, or we need to determine the temperature at point 2. We have temperature at point 1, binigay sa problem. Cp, that is constant, gamitin natin kapag hindi binigay. And mass ng air, yun nga, kailangan natin ma-determine yan using PV equals MRT. Okay, and yung last na hinihingi is the amount of cooling water per minute kung yung inlet and outlet temperature ng cooling water from the intercooler are 15 and 40 degrees Celsius respectively. So assume daw yung value ng index, which is 1.35. So this is polytropic kasi less than 1.4. Assume the intercooler pressure for minimum work and perfect intercooling. So binanggit sa problem na perfect intercooling, so satisfy yung condition natin na dapat perfect intercooling para ang temperature sa paglabas ng intercooler is the same as temperature na papasok sa ating first stage compression and no pressure losses dun sa ating intercooler. So our value is 0.287. Binigyan tayo dito ng hiwalay na specific heat ng air which is 1.0035. Okay? So we know already the approach to calculate that. Then ilipat lang natin. So yung una class is yung required power kapag two-stage at kapag single-stage tayo. So kapag two-stage, then gagamitin natin yung equation na to. Do we have the pressure at the inlet? Yes, that is 1 bar. The volume at the inlet or the free air delivery. This is free air delivery. That is 16 cubic meters per minute. So walang problema. Convert lang natin yan later on into second para ma-cancel and maging kilowatts. Intercooler pressure. Siyempre, wala tayo yan. Pero makakalculate naman natin yan using this equation. Okay, so it will give us 3.241 bar yung pressure natin sa may intercooler. So dito pala is 3.241 bar. Ano class? So i-divide nyo lang yan, 10 bar divided by 10, 3.241. Ang sagot yan is 3.241 din. Hindi, wait lang. 3 square root of 10. Sorry. It's 3.162 pala. That is 10.5. Okay. So tama pala, that is 10.5 bar. So this is not 10 bar, rather this is 10.5 bar. So 10.5 divided by 3.241, that will give you 3.241. Okay, then 3.241 divided na sa 1 bar, then of course that is 3.241. So parehas lang yung pressure ratio ng dalawang compressor natin. So substitute these values here. 10 is equivalent to 1.35. So yung makukuha natin value dito plus is 73,170 watts or 73.170 kilowatts. Okay? Kapag single stage naman, then we can use this equation. Ang pinagkaiba lang na class is yung ating pressure at point 2. Yung pressure at point 2 na dito, hindi na natin ito gamitin si intercooler pressure kasi nga directly from point 1, kinumpress na yung ating air up to 10.5 bars. So it will be this equation, substitute yung P2 with 10.5, and it will give us a value of 86,250 watts. So from this class, mapapansin nyo na mas malaki, comparatively, mas malaki yung value ng power required para may compress yung air from 1 bar to 10.5 bar kapag single stage compressor ka, compare mo kapag may 2 stage. Medyo malaki yung difference nila, di ba? So for that reason, medyo efficient pala ang 2-stage compressor compare mo kay single stage compressor. So next na hihingi class natin is yung temperature at the outlet. So yung temperature na kapag single stage, kukunin natin yung T2, while kapag 2 stages tayo, is either T2 o T3 yung kukunin natin. Parehas na naman yung value niya. So using this equation, T3 equals to T1 multiplied by P3 over Px raised to n minus 1 over n. Ang value natin is approximately 400 Kelvin. Okay? Well, kapag kay single stage, T2 equals to T1 raised to P2 over P1 raised to n minus 1 over n. Yung P2 natin dito plus is 10.5. Ang value natin is approximately 541 Kelvin. So by the temperature difference din, makikita nyo na mas malaki ang temperature at the outlet ng single stage compared kay 2-stage compressor. As I said, that will make sense kasi may intercooler naman tayo during multi-stage. So pinapalambig niya yung temperature na papasok sa second stage, kaya mas relatively lower yung temperature ng ating 2 stages compare kay single stage. Okay? So ayun, by power and by temperature, outlet temperature, mas preferable gamitin kapag ganito nakataas yung ating pressure ratio is yung ating 2 stages compared kay single stage. And next class na hinihingi is yung heat na nare-reject dun sa ating intercooler para mapapalamig yung compressed air. So gagamitan tayo ng MCP multiplied by delta T. Yung change in temperature natin is temperature at point 2, which is equivalent to T3 nga. Actually, kinumpute ka na yan dito, class. And pares lang sila ng value. So that will be approximately 400 Kelvin. Minus temperature at point 1, or dun sa inlet temperature ng ating fluid sa low pressure stage, which is 294 Kelvin. Binigay naman sa problem yan. Yung CP, binigay din sa problem as 1.0035 kilojoules per kilogram Kelvin. So makakancel natin yan. Pero kung hindi binigay sa problem class, we can use 1.005. Kung ako nagkakamali, yung nilagay ko doon. Kilojoules per kilogram Kelvin na. And for the mass of the air, we can calculate that using this equation. PVMRT, wherein at suction side or at free air condition natin siya i-calculate. So yung nakuha ko dito is 8.96 kilograms per minute. So substitute all the values, makukuha natin heat rejected sa intercooler is equivalent to 1,992.44 kilojoules per minute, since per minute yung hinihingi sa problem. Pero kung i-convert mo sa kilowatts, then 33.2 kilowatts. Lastly, yung hinihingi is yung ating mass of water na required para makul na yung air sa loob ng intercooler. Yung ating intercooler kasi serves as a heat exchanger na class. So at the same time, kapag pumasok yung air dyan sa mga tubes, merong cold water na nagpapalamig dun sa air na yon. And ang pinapakalculate is yung required mass flow rate ng water na yon para mapalamig yung ating compressed air. So ang ating analogy dyan is that heat rejected by the air per minute is equivalent to heat gained by cooling water per minute. So kung ano daw yung heat na nare-reject sa intercooler, siya naman yung na-acquire or nag-gain ng water. So i-equate mo lang yan. Then MCP delta T ka ulit. Yun nga lang, sa side ng water mo kukunin. So mass ng water, specific heat ng water, and change ng temperature ng water. Yung change ng temperature ng water, binigay sa problem, 15 Celsius and 40 degrees Celsius respectively. Specific heat ng water, that will be 4.187 kilojoules per kilogram Kelvin. Hindi siya binigay sa problem class, pero remember nyo na lang, pwede natin gamitin yan for standard conditions, okay? Or for general condition. Then, one unknown, one equation, makukuha natin yung mass ng water as 19.03 kilograms per minute. Cancel. Kelvin, we have Kelvin here. Cancel. So, ang unit dito will be kilograms per minute. So, nasatisfy natin yung hinihingi sa problem. Okay, class? Clear ba sa inyo yung ating air compressor?
Yes po, sir.
Okay, thank you very much. Sana naiintindihan nyo, sana may napulot kayo sa discussion natin. So, I tried to summarize yung ating compressor. Kasi technically talagang mahaba ito kasi. Apat na example pa nga lang yung binigay ko dito. What else? So yun. So, naibigay ko na naman sa inyo yung feedback regarding sa final examination, ano yung magiging content. So, please do your best na lang, class. Not only to my subject, even to other instructor. Yung pending ko sa inyo is yung homework natin. Well, nasa second section na ako to the last. So, kayo kasi yung pinakahuli kong klase. So, after nun, kayo na isusunod ko. Matatapos na naman yun by this week. And yung ating quizzes or yung problem set na ginawa. Matatapos ko yun by this week. So, mabibigyan ko kayo kagad ng rough estimate kung ano yung grade nyo. Okay? So, kung wala na tayong tanong, class, thank you very much. Thank you for attending our class and hopefully may naiintindihan tayo all throughout sa mga discussion natin. Good luck sa inyo. Good luck sa inyong finals. Okay?
Thank you po, sir. Thank you po, sir.
Thank you po, sir.
Mhm.
Thank you po.
Thank you po, sir.
Thank you po, sir.
Okay. Good luck sa inyong class na.
Thank you po, sir.
Yes, Junel. Nag-raise ka ng kamay?
Apo, sir. Sir, doon lang po pag may ano po. Pag po halimbawa po ay madaming intercooler, paano nga ulit
Oo.
yung pressure po doon? Saka paano po gagamitin sa
Kasi, di ba yung ating intercooler, saan ba yun? Okay, ito. So yung intercooler nga natin dito, class, is as I said, perfect intercooling, okay? Or complete intercooling. Meaning yung every pressure ratio dito is just the same lang. So yung pag-determine dito ng pressure sa intercooler, pwede natin gamitin yung equation daw na to. Pressure sa intercooler is equivalent to square root or the S square kung ilan yung stages natin, multiply from the first or the initial pressure at the inlet and the final pressure. Pero ito, i-raise natin siya sa S minus 1. Okay? Then yung kalalabasan niyan, class, is ganito. Sorry. Okay. So, pwede tayo magkaroon dito ng mas marami pang, halimbawa, 3, mas marami pang intercooler pressure. Okay?
Sir, bali po yung SI po yung ayun po yung number ng stages.
Number ng stages yan. Then yung pressure ratio nga dito, for example, P sub X, kung una muna na kukunin dito is, okay, since yung pressure ratio nga natin dito, class, is equal lang naman. So, for example, P2 over P1, yung pressure ratio dito, class, will be P3 over P2, and dito will be P4 over P3 lang naman. Okay? So, for every stages, every pressure ratio, equal lang naman daw sila kasi nga walang nagiging pressure drop. So, from that, pwede natin makuha ngayon yung power o yung work. Kasi we have work here, pwede mong kunin siya as 1, then i-multiply mo lang kung ilang stages yan.
Okay po, sir. Thank you po.
Okay? So, anything else, class? Thank you for your question, ha? Okay, so kung wala na, class, then, ayun, good luck sa ating final examination. Thank you very much for attending our session.
Thank you po.